Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions on space and universe for CIE IGCSE Physics Paper 3 and Paper 4. We will divide this video into two parts. In the first part, we will talk about questions for Paper 4, and in the second part, we will talk about questions for Paper 3. And this video is very important because in the coming exam, maybe you will see the similar type of questions from this topic in your exam. So watch this video carefully and try to improve your conceptual understanding of this new topic. For question number 1, it is given to us figure 1.1 shows the orbit of a comet around the sun. X, Y, P and Q are different positions on this orbit. So this is elliptical orbit, and X, Y, P and Q, these are positions on this orbit. And sun is located here. So this is the sun. Beautiful sun is located at this point. For part A1, state how the speed of the comet changes as it moves from X to Y. So when comet moves from X to Y, we need to state how the speed of the comet changes. Is the speed of the comet is increasing? Is the speed of comet is decreasing? Or speed of the comet remains constant? So as comet moves from X to Y, in this case, we can simply say comet is getting closer. Comet gets closer to the sun, gets closer. So as comet gets closer to the sun, it means that the separation between sun and the comet decreases. Separation decreases. As separation decreases, it also means that GPE of the comet decreases. And total energy of the comet remains constant in this case because there is no friction, there is no air resistance. So the total mechanical energy of the comet remains constant. So if GPE decrease, it also means that kinetic energy will increase. So if kinetic energy of the comet increase, but mass of the comet remains constant, so it means that speed of the comet will increase. And so simply we can say speed of the comet increases. So we can say speed of comet increases. So we can say speed of comet increases in this case. So if you want to write down your answer in a proper way, so this is how you can write down your answer. And this question has only 1 mark, and that is a B mark. Meaning this one has to be in your answer. Now if you go to the second part, the question is asking us to explain in terms of energy transfer your answer to A1. Actually we have already discussed. As comet is getting closer, separation is decreasing. So the GPE is decreasing and kinetic energy of comet is increasing. So the speed of the comet is increasing in this case. So the energy transfer we have already discussed. So let me show you how you can write down your answer. So this is how you can write down your answer. But let me explain you a little bit more about this. Let's say when the comet is at this point, we will discuss few points and we will discuss this point when the comet is here. At this point, you can see separation between the sun and the comet is maximum. So separation is maximum. So we can say separation is maximum. So at this point, GPE of the comet is also maximum. So we can say GPE here is maximum. So at this point, GPE is maximum. Now if you look at this point, at this point, separation is minimum. Separation is minimum. Means separation between comet and the sun is minimum. As separation is minimum, it means that GPE of the comet is minimum. So GPE minimum. So we can say GPE is minimum. Actually, when we talk about the potential energy, this is the energy of the system. So at this point, energy of the system is minimum. And kinetic energy of the comet, kinetic energy, this one will be maximum. So these 2 points are very important. At this point, GPE is maximum. At this point, KE is maximum. And also it is very important to understand when the comet is moving from, let's say from this point A to this point B, in this case KE is increasing and GPE is decreasing, and vice versa is true when the comet is moving from B to A like this. So in this case, KE is decreasing and GPE is increasing because the separation between the sun and the comet is increasing. So GPE is increasing. So these are some beautiful points you need to understand about this elliptical orbit. I hope these points are clear to you. And this question has 3 marks. So if you write down these 3 points, if you write down the first point, as the comet moves closer to the sun, you will get 1 B mark. So this is 1 B mark. And the second mark you will get if you have written gravitational potential energy of the comet decreases, you will get another B mark. And the last one, if you say kinetic energy decreases, you will get another B mark. So this is how these 3 marks will be awarded to you. And these are the 3 points you have to write down to get these 3 marks. For part B, it is given to us the shape of the orbit of the comet from P to Q is circular with the sun at its center. State and explain the changes, if any, in the speed and in the velocity of the comet as it moves from P to Q. So the first thing we need to understand, it is given to us that the orbit from P to Q, this orbit is circular. If this orbit is circular, so it simply means that the angle between force, so this is the centripetal force and this is the gravitational force, and angle between velocity, so this is velocity of the comet, and angle between force and velocity is 90 degrees. So it means that in this case, the work done by gravitational force, this one will be 0. As work done by gravitational force is equal to 0, so in this case, this force will only change direction. So we will say change in direction only. So the gravitational force will only change direction. So it means that the magnitude of the velocity will not change. So we can say the speed will remain constant. Speed will remain constant because speed is magnitude of velocity. So it will remain constant because work done by the gravitational force will be equal to 0 because angle between them is equal to 90 degrees. Now if you look at the velocity of the comet depends on the magnitude of the velocity, but in this case magnitude is constant. Magnitude of velocity is constant, and direction of the velocity in this case is changing continuously in the circle. So we can also try to understand a little bit more about that. So let's say when the comet is at this point, velocity is this way, and when the comet is here, direction of velocity is this way, and when the comet is here in this circle, direction of velocity is this way. So you see, direction of velocity is changing all the time, but magnitude is constant. So it means velocity is changing because direction of velocity is changing. So we can say in this case velocity changes, but speed remains constant. Why speed remains constant? Because distance of the comet from the sun remains constant because it is assumed that this is a circle, so the distance between the sun and the comet remains constant. So we can say speed remains constant because distance between sun and comet remains constant. So we can simply say distance constant. And velocity changes because direction of motion of the comet is changing all the time. So the velocity is changing continuously, but speed is constant. So these points you have to mention in your answer. So let me show you the answer. This is how you can write down your answer. And this question has 4 marks. If you have written these 4 points, you will get 4 B marks. So this will be 1 B mark. Speed is constant because the distance from the sun is constant. So if you write on the second point, you will get 2nd B mark. And 3rd B mark you will get if you have written velocity is changing. And the 3rd point, 4th B mark you will get if you have written as direction of motion of the comet is always changing. Means first you need to write down speed is constant, then you need to explain because question is asking you state and explain. So first of all you will state speed is constant, then you need to explain why speed is constant, then you will state velocity is constantly changing, then you need to explain why velocity changing. So if you write on these 4 points, you will get 4 B marks. So this is how marks will be awarded for this part of the question, and this question is for P4. paper 4. So it's very important for paper 4 exam. For question number 2, part A, we need to explain why the moon is visible from our planet. Moon is a satellite and the moon is orbiting around our planet. So this is a natural satellite and moon does not emit any kind of light, but still we can see the moon. So how do we see the moon? Moon is visible to us. It's due to reflection of light from the sun. When the light from the sun reflects from the surface of the moon, light reaches our eyes and we can see the moon. So simply you can say it's due to reflection of sunlight from the surface of the moon. So if you write on these points, you will get 2 marks. Light from the sun is reflected, you will get 1 B mark. If you have written from the surface of the moon, you will get another B mark. So this is how these 2 marks will be awarded. For part B, figure 2.1 shows some of the phases of the moon as seen from our planet. For part B1 on figure 2.1, we need to draw the phases of the moon for day 7 and for day 29. So for this question, simply you need to remember phases of the moon and also you need to be able to draw them. Now if you look at the phases of the moon, so here we have the full moon. This is the new moon. We can start from here. So we have this one is new moon. And next one, this one is half moon. So this will be after 7 days. So this one will be after 7 days. And after 14 days, we will have a full moon. So this one is after 14 days. We will have full moon. And here we will have half moon again. And this one will be after 22 days. And this one again we have after 29 days we have new moon. So this one is the new moon here. So this is after 29 days or we can say after 0 days, the new moon. So we have to draw these 2 phases after 7 days and after 29 days. So let me show you how you can draw these phases. So this is how you can draw half moon and this one is the new moon after 29 days. So these 2 phases you need to draw. If you have drawn these 2 phases, you will get 2 marks. One here, one here. So this is half moon and this one is new moon. Now for the next part, for the second part, we need to state what the phases of the moon indicate about the motion of the moon. So simply the moon is orbiting around our planet and duration of the moon's orbit is around 27 to 30 days. Around 27 to 30 days. So this is only telling us about the motion of the moon about our planet. So for this one, you can simply say motion of the moon. So in this case, moon is orbiting our planet and moon takes around 27 to 30 days to complete one cycle. So moon orbits our planet and the duration of the moon's orbit is about 1 month. You can say about 27 to 30 days. So you will get 2 marks for this one. If you have written this one, moon orbits Earth, you will get 1 mark. And the second mark, if you have written about the durations of the moon's orbit, means moons take 1 month to complete one cycle around our planet. So you can see from here we have the new moon. So then you complete this one cycle in about 27 to 30 days. So if you write on these 2 points, you will get 2 B marks. So this will be the second B mark. This is the second B mark. So this is how you will get 2 marks. For part C, it is given to us the average radius of the moon's orbit is 3.84 times 10 to 5 kilometers. The moon's average orbital speed is 1025 meters per second. We need to calculate the time period for the moon to complete one orbit of the Earth. Mean one cycle around our planet. So simply first of all, we can draw, this is the cycle, moon will follow. Moon will be moving in this cycle. So we can draw beautiful moon here as well. And this one is our beautiful planet. So this one is our planet. And in this case, it is given to us the distance from orbital radius is given. Orbital radius. So this is the orbital radius. We can say this is capital R. orbital radius, and the speed of the moon is also given to us. Average orbital speed is given. So the average orbital speed, we can simply say orbital speed. We are talking about average orbital speed. This will be equal to the total distance traveled by the moon in one cycle. That distance will be equal to 2 pi r divided by time taken, so the time period. For this question, we need to calculate time period. So simply we can say time period will be equal to 2 pi r divided by orbital speed. So we can simply say this is V naught, average orbital speed. So we have in this case 2 pi, this is constant. Orbital radius is given, but this is given in kilometers, so we have to convert into meters. And so this will be equal to 3.84 times 10 to 5 times 10 to 3 divided by orbital speed, that is 1025. Now if we solve this one, in this case our final answer will be equal to 2.35 times 10 to 6 seconds. So we can use our SI base unit. So the final answer is 2.35. This one has to be up to 3 SF because the least number of SF in the raw data, in the given data, we have 3 SF. So you have to use 3 SF. So this is 10 to 6. So this is how you can answer this question. And for this question, if you have converted this one into meters, you will get 1 mark, 1 C mark. And the second C mark you will get if you have written this formula. So you will get another C mark if you have written this formula. You will get C mark. And you will get A mark if you have got the right answer. So this is how these 3 marks will be awarded to you. For our third question, part A, it is given to us light from glowing hydrogen in distant galaxies is redshifted. Describe what is meant by redshift of light. Redshift of light simply means that the wavelength of observed light, we can simply say the wavelength of observed light is greater than the wavelength of light emitted from the star. So we can say E emitted, light emitted from the star, light emitted. So this one we can say light emitted. So this is meaning of red shift. So how you can write down the answer? So simply you can say in this case, wavelength of observed light is longer than wavelength of light being emitted from the distant galaxy. So in this case, you will get 2 marks, 2 B marks. First mark you will get if you have written wavelength of observed light is longer, you will get 1 mark. And then if you have compared this one with light emitted from the distant galaxy, you will get another mark, another B mark. Now, if we go to the second part, we need to state what can be deduced from the redshift of light from glowing hydrogen in a distant galaxy. So as light is redshifted, it simply means that distant galaxy is moving away. So you need to understand, if the light is redshifted, it means that galaxy is moving away. So galaxy moving away. So simply we can say galaxy is moving away. And by comparing wavelength, means if we have wavelengths delta lambda by lambda, we can find out the speed of the galaxy, means the recessional speed of the galaxy. We can calculate if recessional velocity. We can calculate if we have the wavelengths, means the wavelength of emitted light from the galaxy and the wavelength of observed light. If we have, then we can compare and we can find out the speed of the galaxy. So you have to write down 2 points in your answer. 1 point you can write down distant galaxy is moving away from us. You will get 1 B mark. And the second B mark you will get if you have written its velocity of recession from Earth can be calculated by comparing the wavelengths. I mean, if you have observed wavelength and emitted wavelength, then we can find out the value of V, because C is a constant. This is speed of light. 3.0 times 10 to 8. If we have the wavelengths, then we can compare and we can find out speed of galaxy. So this is how you need to answer this question. For part B1, we need to state one method for estimating the distance d of a distant galaxy from the Earth. So to estimate the distance of a distant galaxy, we can use standard candle. There are different methods, but we can simply use standard candle. So easiest one at this level, we can use standard candles. An example of standard candle is supernova. Supernova is a standard candle. Supernova. Standard candle simply means that the luminosity of that object is known, and we can use that luminosity and we can find out the distance. So the luminosity if we have, so then radiant flux intensity, this is equal to 4 pi d square. Then radiant flux intensity easily we can determine by observing the light on the surface of our planet. So if we have value of this one, if we have this value and this one we can find out, then we can find out value of t. So simply we can use standard candle. And so how we can write down our answer? For the answer, simply you can say using the brightness of a supernova in a distant galaxy. So we can determine the distance. Another example of standard candle is Cepheid variable stars. So these are also one class of stars, Cepheid variable stars. We can also use as a standard candle and we can estimate the distance of distant galaxies. So this is how you can answer. Now if we go to the second part, we need to explain how according to the Big Bang theory, 1 over h represents the age of the universe. If we look at Big Bang theory, according to Big Bang theory, everything just started from a point, and then this matter the energy was concentrated at one single point. Also you can say matter and energy, they were concentrated at single point. Then energy converted into matter, means there was a creation. So we can simply say energy was concentrated at this one single point. Then energy converted into matter, that is what we call creation of the universe. And in this case you can simply say as the time is passing, every galaxy, if you see this galaxy for example here, this galaxy here, everything is just moving away from each other. Now if we have any specific galaxy, for example this galaxy, if we know when this galaxy was close to our Milky Way, means over galaxy Milky Way, so this one is the Milky Way. So if we know the distance this galaxy has traveled from us, means from the Milky Way, and also if we know the speed of this galaxy, we can say, let's say this galaxy A. So if we have the distance of galaxy A from us, and also we know the speed of this galaxy, the speed at which this galaxy is moving away from us, so we can find out the time. So we can now find out the time, how long this has taken to go away from us, the time when these two galaxies were together. So we can calculate that time, and that time simply you can calculate that t. And t will be equal to distance over v. But in this case, we are assuming that speed is average speed, or you can say, or we can say, we are saying in this case, speed is constant. So we are saying speed is constant. So this is t is equal to d over v. And that is the distance galaxy has traveled from us. And v is the speed of the galaxy. So we can calculate value of t. We can calculate time. And this time, this is equal to 1 over h naught. So this is 1 over h naught, and h naught is the Hubble's constant. So this is Hubble's constant. So this h naught is Hubble's constant. So that's the reason here it is written 1 over h naught represents the age of the universe. So the time when these two galaxies they were together, and if we can find out the time, how long this galaxy has taken to move away from Milky Way until now, that distance if we have, and we can calculate the time, means that is the age of the universe. So 1 over h naught is representing age of the universe, because this t is the age of the universe. So these points simply you need to understand to write down the answer for this question. So let me show you how you can write down the answer. So this is how you can write down the answer. So these points you have to write. You can say according to Big Bang theory, all galaxies matter originated from one point and time in space. If the distance a galaxy has traveled from when it was in contact with the Milky Way, means when the Milky Way and galaxy A they were together, and we can find out the distance traveled by the galaxy. Let's say that distance traveled by galaxy A is t, and the speed it has been moving, let's say, is v. then the time simply we can say will be equal to d over v, and this one is equal to t. So actually this one has to be 1 over h. So this is 1 over h now. So this is the time from the Big Bang, or we can say this is the time from the start of the universe. So 1 over h naught is representing age of the universe. So very simple point, means at one time these two galaxies, they were together, then they separated, they start moving away from each other. And so if we have the distance traveled by the galaxy D from us, and we have the time, so we can calculate, then we can calculate if we have distance and we have the speed of the galaxy, we can calculate time, and that time is age of the universe, and that time is equal to 1 over h naught. So 1 over h naught, it simply means that is representing age of the universe. So this is how you can answer this question, and until now we have discussed questions about P4, and now we will discuss question about P theory after this. For question number 1, part A, we need to state the name of the force that keeps the earth in orbit around the sun. Means why this earth, this stay in the orbit. So there is a force of attraction between earth and the sun. Then that force of attraction we call is gravitational force. So simply we can say the answer for this question is gravitational force. So we can write down gravitational force. And if we go to the second part, is asking you state how many days it takes the earth to complete one orbit of the sun. So one orbit around the sun, so it takes around 365 days. And if we go to part C, question is asking us to explain why the sun appears to move across the sky each day. The reason is that because the earth is rotating around its own axis. So that's the reason sun appears to move across the sky, because earth is orbiting around, earth is rotating around its own axis. So this is the axis. So earth is rotating around its own axis. So that's the reason sun appears to move across the sky. So simply we can say earth is rotating about its own axis. So you can say earth rotates on its axis once every 24 hours. Means in one day earth complete one rotation about its own axis. So these are the answers for this question. So these are pretty straightforward points. So these points you have to keep in your mind for P3 and also for P4 exam. And these questions, each part in this question has 1 mark, so this is B mark, and this is also B mark, and these are 2 B marks, B1, and this is another B mark. For question number 2, part A, we need to complete the sentences about objects in our solar system. Question is asking us planets, minor planets, and orbit the sun. So if you look at this one, this is our beautiful sun. So this one is the sun. So we have planets, they are orbiting around the sun. There are minor planets like Pluto, and also we have asteroids and comets. They also orbit around sun. So we can write on asteroids and we can write on comets. So simply we can write down asteroids, they orbit around sun, and also comets. So we can also write down comets. They orbit around sun. The objects that orbit planets, we call them moons, or we can call them natural satellites. So this is how we can answer part A. For part B, we need to compare the structure and size of the 4 inner planets with those of the 4 outer planets of our solar system. 4 inner planets. So these are 4 inner planets. And these 4 inner planets, they are rocky. So we have to compare their structure. They are rocky. And these 4 planets, 4 outer planets, you can see this is asteroid belts. So these planets are outer, these are inner planets, means as compared with this belt. And these planets are gaseous. They're just gas. So they are gaseous. Mean they're not solid or rocky, we can say. And these, if you look at the size of them, you see this size is very small and this size is big. So we can say these are giant, gaseous giant. So the size is bigger. So if you have understanding of these points, so now we can write down inner planets and outer planets. So these planets are rocky, these planets are gaseous, and they have larger size. So let me show you the answer, how you can write down in a beautiful way. So this is how you can write down your answers. So simply you can say these are rocky, you can say these are gaseous giants, and outer four planets, they are larger than inner four planets, mean the size is bigger. So if you write on these points, you will get 5 marks. This question has 2 marks, so if you write on this one, you will get 2 B marks. You will get 1 B mark here and 1 B mark here, and the last B mark if you have compared the size, you will get here, because question is also compare the structure and size. So structure you have compared rocky and gaseous, the size you have to compare as well. Then you will get 5 marks for this question. For third question, part A, we need to state the names of 2 main elements found in the sun. Sun is mostly made of hydrogen and helium. So simply we can say sun is made of 2 main elements, and those elements are hydrogen and helium. And this question has 2 marks. If you have written hydrogen and helium, you will get 2 B marks. So we can simply say 2 B marks you will get. For part B, the sun is one of the many billions of stars that make up our galaxy. It means our galaxy consists of billions of stars, and sun is one of those stars. We need to complete the following sentence about our galaxy. Our galaxy's name means, what is name of our galaxy? Name of our galaxy is Milky Way, and you can see this is beautiful galaxy, and sun is located somewhere here. And if you compare the distance of the sun from the center of the galaxy, this is about 28,000 light years. Mean if the light travel from the center of the galaxy and reach our sun, light will take 28 years, and that is the distance between the center of the sun to the center of the Milky Way. So the name of galaxy simply we can say is Milky Way. So this is name of the galaxy. Now if you go to the next question, part C. For part C, it is given to us the distance of Mars from the sun is this one. Speed of light is this one. Mean the distance between sun, so simply you can imagine that this is sun, and you can imagine Mars is located here. So this is the Mars. Distance between centers of sun and the Mars is given to us. That distance is 2.4 times 10 to 11 meters, and the speed of light is given to us. We need to calculate the time for the light from the sun to reach the Mars. It simply means that if the light travels from the sun, how long this will take to reach the Mars, that time we need to calculate. But we have the distance and we have the speed of the light. So simply in this case we can say the speed will be equal to distance over time, and we need to calculate time in this case. So the time will be equal to distance over speed, and distance is equal to 2.4 times 10 to 11 meters. You have to be careful with units, and the speed of the light is given, that is 3.0 times 10 to 8 meters per second. So if we solve this one, our answer will be equal to 8.0 times 10 to 2, means 800 seconds. So simply you can say this is equal to 8.0 times 10 to 2 seconds. And this question has 2 marks. If you have written in this case the formula, you will get 1 C mark. So if you have written this one, you will get 1 C mark. If you have written this step, you will get 1 C mark. And if you have got the right answer, you will get another mark, and that is a mark. So this has 3 marks. So 1 mark you will get for writing the formula, 1 C mark. 1 C mark if you plug in these values, and the final mark is the answer mark. If you got the right answer, you will get 3 marks for this question. And that's all for these questions. We have discussed 6 questions about space and universe, and these 6 questions are very important for P4 and also very important for P3 exam. So first 3 questions are only for P4, and last 3 questions they are P3, but all these 6 questions you need for P4. So go through these questions, watch this video carefully, and try to improve your conceptual understanding of this topic. And also these questions are very important for your exam because there are not too many resources available for space and universe, because space and universe is a new topic in CIE IGCSE physics. So these questions are very important for your exam. And also if you like this video and if this video was helpful, so please like and subscribe the channel, because your encouragement is very important to make more videos. See you in next video.